I'm Rob Waldie from Opengear. You may know us as the console server company, or maybe even the Outofband cellular company. But today I'm not here to talk about our latest little management appliance, little devices that we make. Even though we are launching one at the show with LTEA and global coverage, which is pretty cool. Just definitely check that out as well. But today I'm actually here to talk about something a little bit different. So today I'm just trying to show you what we're building and allowing our users to build. Really using the resilient Outerband fabric that our system creates, and actually utilizing that as a software application platform. So really, it's all about leveraging the availability and resilience of our system, and also the presence of our management agents, our hardware management agents, console servers, and the proximity they have to the infrastructure under management. So really, at the end of the day, that allows you to automate even the darkest corners of your network. So just starting with a quick agenda, and here's how I'm hoping this will all go. Just a quick corporate overview to begin with. Then I'd just like to step back real quick and just share a bit of context and really about how our products are being used in operations today. And in particular, with how operations is handling some of the challenges around infrastructure at scale, particularly infrastructure decentralization to the edge, and also automation and adoption of automation. Then hopefully I'm not going to spend too much time in PowerPoint. It'll be kind of 50-50. Then I'm going to jump over to a live demo. If the demo gods are smiling, I'll be jumping into a GitLab account that I created a couple of weeks ago, and I've set up a CI/CD pipeline that actually hooks into the Outerband network, so you can check in some config into GitLab, and then it provisions a switch on an edge network without requiring any kind of in-band connectivity, so no LAN, no WAN in place. It's all going to happen through this NetOps Automation Platform I'll be talking about today. So just a bit of a backgrounder about Opengear. We've been around for the past 15 years. We've got a presence here in the States, in Utah, our headquarters over in Jersey. We've also got a development office over in the Bay Area. We've got a large engineering presence in Australia as well, which is where I'm from. So in that last 15 years, we've really, I guess, established ourselves as the market leaders in out-of-band management. And really that's been through trying to push the envelope, I guess, about what out-of-band management is, and really try to tackle some of the root causes, and not just be just the console server where you're basically a break-fix kind of band-aid for the network, but try to tackle some of those root causes around network availability and network resilience. So we've got models, I guess, for all shapes and sizes, from the traditional data center, big 1U rack mount console servers, but also we've got little boxes that deploy into all sorts of smaller deployments as well. So maybe your branch, your edge data centers, and things like that. We've got ones along roadside cabinets. We've even got one of our units down on the bottom of the ocean floor off Hawaii in a deep sea observatory where they've got some infrastructure that's monitoring some seismic activity down there. So similarly, our customer base, it really ranges from the top tree, tier 1 ISPs and tech unicorns and things like that, all the way through your Fortune 550 enterprise, all the way down to your mom and pop type managed service providers. So we kind of run the full gamut. And they're all using our equipment and using our system in similar but slightly different ways, which is kind of what I want to talk about today. And it would be remiss of me not to plug our booth since it's Cisco Live here. So stop by 2728, and apparently we have socks to give away. If you're into socks, we have plenty of socks. So just another quick introduction about myself. I've been with Opengear for most of its 15 years. So my background is as a firmware developer working on the firmware for our appliances. But in 2010, I actually relocated over to Europe. And really that was when we were still a smaller company, to establish a technical presence over there and help grow the business over there. I found in that time I really loved getting my hands dirty and working with customers and really applying our system to solve some of these real-world operational problems. But all good things must come to an end. 8 years and 2 kids later, I've relocated back to Australia, so back in the engineering office. And my current role is a product manager of these NetOps modules that are built on our NetOps Automation Platform I'm talking about today. And again, it's cool to be able to kind of build this software and really apply our system to solve these operational problems. I still get to write code occasionally. They still let me write code, don't let me check it into production. But I get to do things like build proof of concepts, and this demo like I've built today and going to be showing off a bit later on. So just a quick bit of a backgrounder. A lot's been changing with networking, both with how networks are configured and how they're operated, with the DevOps style network automation in particular, and appliance programmability really in the mainstream. And enterprises are getting serious about implementing network automation. It's not just kind of confined to your leading edge kind of tech companies. Also, the topology of the internet's changing itself. So a lot of what we think of as the cloud is actually decentralizing into these kind of edge data centers. So there's a couple of these concurrent trends that are going on. And at the intersection of these two is really a couple of applications, or one application I'd like to show you today about remote edge provisioning, where the Outerband network is really there to help address a couple of these very specific challenges. So again, just kind of stepping back a little bit about out-of-band management. So I'd like to share the apocryphal tale of the first console server. So it was back in the days, I guess, when the internet really was kind of exploding. With the web became a thing, and I guess there were a lot of digging men and the blink tags, I guess, floating about. But I think it was in the Yahoo data center where basically the engineers there were getting tired of running around up and down the aisles with their crash carts, plugging into RS-232 consoles of servers to bring them back to life, kind of thing. So I was like, well, I wish we could do this over the network. So it turned out there was actually a box that let them do that already. It was a terminal server that was originally designed to hook up these dumb terminals to over the modern Ethernet networks. So converting RS-232 out to Telnet. So what they did is they basically reversed the sense of the terminal server, and they were able to Telnet into their RS-232 consoles from their desks, hence reverse Telnet. So that was the first console server really, and over time these repurposed terminal servers became console servers with a lot of these purpose-built kind of features being built out, things like logging and monitoring and alerting, and that's really kind of evolved into smart out-of-band, and that's, I guess, Opengear have been talking about that for a little while. And that's about being more than an access solution, about being aware of the environment, being able to also control things like power, monitor power, and do some, I guess, rudimentary or on-box automation as well. We call it runbook automation, whereby you can take some correlated kind of inputs, like things like pattern matching, say a string on the serial console, realizing a box is locked up and automatically rebooting it. So having this smart capabilities built into the appliance itself, the management appliance itself. But still fundamentally, we're talking about the application of out-of-band being about connecting human operators to devices. But now we're starting to move into the next era with network automation, as represented by Bender up there. This history lecture, I guess, kind of prompts the question why, 30, 40 years later, am I sitting here talking about RS-232? Why is it still relevant? And the reason why is because, by and large, console access into individual network devices like routers and switches are still how networks are managed. So individual console operators, highly trained, certified, and highly skilled, handcrafting and hand patching configs, kind of running configs. But what this leads to, I guess, is a situation where you have a bunch of subtle and sometimes not so subtle differences into maybe two routers or power routers that are supposed to be configured more or less identically, but actually are quite subtly different. And because you're patching all this configuration in place, there's no kind of audit trail and in-place documentation and things about what was done by whom and why. And this has really led to a situation of there's a lot of kind of really fragile kind of networks out there. And I guess a bit of a culture of fear, I guess they talk about, around changing anything or touching anything in the network. Because if you don't have like automated testing, you don't really have a guarantee that your change isn't going to break some kind of change that was made a year or two ago. And then break the network. So config craft kind of builds up and ossifies and things like that. And when things break, pages go off, everybody kind of reacts, and they log in through console servers and fix things up. So that's kind of how things that's kind of the state of play for a lot of network operations today. In this kind of environment, we're talking about scale meaning more. You got Bigger networks means more operators, reacting, but often it means the existing team have just worked harder. But managing infrastructure at scale, we're talking about we're talking about issues of scale here. And managing infrastructure at scale is a solved problem if you go over to the system side, right? So the DevOps movements, really kind of came into its own, maybe say 5 years ago, I guess. And really that's about applying these software development practices to operations. The central dogma that I'm sure we've all kind of heard ad nauseum by now is infrastructure as code. But to me, really, that just means that infrastructure configuration should be treated like software source code. So, at its most basic, you store it in a central config repo, and patches are made in meaningful change sets with, commit messages that describe why things are being done and who did them and when. It also means that you can do continuous integration. So if a change is made, you can just do something, it can be as basic as automatically checking for typos by way of an automatic linter. So basically running some test scripts over your config to make sure there's no bad fat fingers or syntax errors or whatever. So if you want to take that a step further from the continuous integration, the CI of the CD into the CD, there's also continuous deployment, which is kind of the next step in the DevOps pipeline. So when all your tests pass, the updated config can actually be automatically deployed to production. And that's what I'm going to demo today. And basically pushing the big Leroy Jenkins button and seeing what happens. So in this kind of environment, we're talking about scale. When we talk about scale, it's really, scale means less. There's less special cases, less complexity, less config cruft building up. And you really, you've just got a simpler environment. It's easy to understand and easy to manage, which is basically what you want in source code as well as network configuration. So, as I said, it's a solved problem. Why isn't everybody doing it today? So it turns out, it's not really that simple to get from point A, the current state of affairs, to this DevOps automation nirvana. A lot of our users that we're speaking to, they want network automation, or they're being asked to implement network automation. But what we're hearing is the path to get there isn't really clear. The network engineers have this really deep domain knowledge in what they do, about packets on the wire and troubleshooting issues and how to implement various routing scenarios. But the infrastructure as code approach actually requires a different skill set. So it requires development skills. And if you're at the top end of town, if you're a tech company or a hyperscaler, you've got these armies of programmers that you can recruit internally, and you can get them to work with and alongside, or even merge teams with the network engineers. But that's not really your typical organisation. That's not the typical organisation that we're talking to. And I think it's well illustrated by this Reddit post that was made. It says 2 months ago. It was actually more like 18 months ago. But really, I think the takeaway here is the automation. It's not all or nothing. There are a bunch of easy wins you can start with, and that's what I'm kind of going to show one of them today. And like this post, I'm going to posit that one of the easy wins is the initial provisioning, the initial configuration deployment to do a remote site turn up. So the second stumbling block is, I guess, like how do you start? How do you get from your kind of reactive break fix model? How do you get to this slick DevOps shop? And I guess, as I said, we've got kind of like a really broad range of customers, and they're all at different waypoints on this automation journey. So what we're really trying to do, I guess, with the NetOps Automation Platform is we're taking some of the lessons that we've learned from our customers who are already really far along, really advanced. They've been kind of automating their networks kind of in non-trivial and quite sometimes quite sophisticated ways, and make them accessible and applicable to your smaller kind of typical network operators. So I'll just go through really quick basically what a typical Outerband deployment looks like at a remote site. I'm just calling it the edge site there. So basically what you've got is an Opengear appliance, one of our physical boxes on site, say a console server, and that'll be connected up via your classic kind of RS-232 console into your routers and your switches, maybe your power infrastructure and things like that as well. And we're just terming them managed devices for the devices under management, your routers and switches and infrastructure they actually really care about, and the Opengear node is one of our management boxes. We also have models that have an Ethernet switch built in as well, which lets us do some extra kind of interesting things on the provisioning side. So I'm adding that to our diagram here as well. We have a central management system, our central management VM. It's called Lighthouse, and really that's at its core providing a central aggregated view of all your Outerband management consoles and giving operators a central way to get in and access all their consoles from a single pane of glass, to kind of coin a cliche. That's a VM that either runs on-prem on their own hypervisor, or it can run out in the cloud as well. So if you're an operator, you're Happy Harold sitting there and you're getting into your consoles and you're making your changes, you've got the safety net of the console server there, until you make a change that actually brings down your WAN connection. Say this is an edge site, it might not have fully redundant links, and it might be pretty easy to actually break connectivity into the remote site. So as I said, we do the cellular Outerband as well. So as the operator's starting to panic, the Opengear node can re-establish a communications path, basically a northbound OpenVPN connection back into Lighthouse over the cellular network. So basically, re-establishing comms into that remote site, allowing the operator to re-establish the WAN connectivity and make everything happy again.
On the management NICs, can you be a server on that, or SIMC for physical server management, or does it have to be console CLI?
It can be anything. Yeah, it's just an IP network connection. So yeah, you can hook up things like your ILOs and your DRACs and things like that. Also, boxes that kind of are web UI first, like some of the new SD-WAN boxes that are coming out. They may or may not have consoles, but they have web UIs that you can drive as well. So you can access them through our system. Yeah, the other thing is as infrastructure starts to get virtualized as well, you might have virtual routers and things like that, and they might be accessed via, the hypervisor console, or via, an lights out management, like an ILO or something like that as well. So, yeah.
Thanks.
So if you kind of take this model and start to kind of scale it out, each of one of these down the bottom is one of these edge sites that I've illustrated. We can really start to rethink the Outerband management network as kind of this highly available fabric. So you've got all these kind of remote management agents that have the presence at remote sites. They have the proximity to the infrastructure. They're physically cabled in by a console and to the management NIC. And you also have like this central controller, I guess, or orchestration point in Lighthouse that's got this resilient connectivity, because all of these management agents are establishing these northbound VPN tunnels completely independent of any kind of inbound infrastructure, because they've got the self-contained cellular connectivity as well. So everything's self-contained and independent of your production infrastructure. So terming that the Outerband fabric. So what the NetOps Automation Platform is really doing is it's enabling software to run as part of the Outerband management network itself. So again, software is running on Lighthouse, running on those remote management agents, completely independent of your in-band or production infrastructure. As I said, yeah, that really leverages our presence, proximity, resilience, but also our logical and physical security. We've got that VPN connectivity that's being established remotely, and our new models that we're launching, our operations manager class of management boxes have a TPM, so they're fully encrypted, they've got trusted boot, and then they're tamper resistant as well, so they'll refuse to boot if they detect any logical or physical tampering. So we're building the system basically by combining a bunch of these standard best practice DevOps components like Docker and Ansible. So we talk about Opengear NetOps modules, and really these are kind of the software components. These are, I guess, the applications that run on the Outerband network on our NetOps Automation Platform. They're fully self-contained. They actually just run as little Docker containers, and they're orchestrated and centrally orchestrated and managed from Lighthouse. And what we've done is we've tried to, I guess, target a bunch of common operational scenarios. We've developed a bunch of, we're starting to develop a few NetOps modules ourselves. And one of those is the provisioning application that I'll show you today. So yeah, onto the actual specific module that we're looking at today, which is called Secure Provisioning for the NetOps Automation Platform. So really we're talking about kind of two two trends that are happening at the moment. One is the decentralization of infrastructure, and the other one is the need or the desire, I guess, to move to network automation. And in particular, one of these easy wins, one of the low-hanging fruit of automation is just bringing things up for the first time. Just, network turn-up, provisioning your infrastructure for the first time through something like zero-touch provisioning. So at the intersection of these, you've actually got a bit of a chicken and egg problem. The question that we're trying to answer is how do you provision a new edge network remotely, securely, and automatically? So the thing is with network automation is you actually need the network there to be able to run the automation tools since they use the network. So if you're looking at something like an agentless approach like Ansible, it needs to be able to go and log into the devices that it's trying to automate via SSH and push its code. Or if you're looking at something like Puppet that runs an agent, that Puppet needs to be able to reach back to the Puppet master. Either way, they need the network there. So if the network isn't there, if you're provisioning a new network, for example, or if the network goes down, then your automation fails. The other thing is, as you're all well aware, I'm sure, that enterprise-grade or serious network infrastructure ships in its default state with tends to have a ZTP, zero-touch provisioning client enabled. So it'll sit there, and as part of its initial kind of bootp, DHCP requests, it'll request, if it gets handed out a URL to a configuration file or a firmware image, it'll apply that and basically attempt to auto-provision itself. So in this scenario, you've kind of got these technologies that require the network to be in place. If you're turning up a new network and you don't have a LAN, you don't have that DHCP service, you don't have the files on site, they're all back in your central data center. So how do you actually get them? How do you bootstrap this LAN? How do you bootstrap this new network? So basically the state of the art, as far as we're able to ascertain, is to pre-stage, get all the racks built out, maybe through a VAR or something like that, which is still a pretty common one. But that tends to, there are pretty big security concerns about that. Having like a contractor walking around with a USB key with all of your sensitive network configs on it obviously isn't ideal. And you also want to, once you've got all those that infrastructure kind of configured, then you have to fairly tightly control the chain of custody from the staging area to where it's deployed in production. And subtle differences between your staging and your production environment can break things, in which case you're stranded and you don't have your remote access. The other one is to fly an engineer to site. That's a pretty typical one, but obviously that's the opposite of automation. So this is the problem that secure provisioning attempts to solve. So basically what secure provisioning does is it turns your Opengear node into a day one provisioning node. So it basically acts as a bootstrap LAN. It runs a DHCP server with all the ZTP file services, so things like HTTP, HTTPS, TFTP to serve all those initial configs, and also provides a DNS relay back into your central network via Lighthouse, and an NTP service for devices that are booting up and generating certificates and things like that need a correct time. The other thing it does is it provide a bootstrap secure WAN connection. So it actually uses its the cellular connectivity of the node, basically can hand itself out as a default gateway for devices as they come up, and also has a route. So if anything's trying to reach the network or networks behind your central Lighthouse central management, it'll route that over the VPN. So basically, from day one, when you've got no LAN in place, no WAN in place, your network routers and switches, as they boot up, can reach all of your core services for doing their provisioning and reach AAA services and things like that.
Are you going to step into the secure provisioning ZTP and how that works? I'm curious, in more detail, or?
Yeah, sure. Yeah, no, that's coming up. I think
Awesome.
next
Then
slide.
I won't ask my questions. I'll wait. Thanks.
Yeah, no worries. Yeah, it's still a bit hand wavy at the moment, but I promise that I do drill down a bit more. So this is all, as I said, centrally orchestrated from Lighthouse. So we've got kind of an easy mode UI. As I said, we're trying to make this automation thing accessible to kind of, to everyone, to their entire user base. So you can actually just configure that through the UI. Or if or you actually can just directly check code into Lighthouse because it runs a little Git repository on Lighthouse, or you can chain into another Git repository using CI/CD, which I'm going to show you today. So I guess the other point to make here is once a secure provisioning node has been actually activated and has had all these resources deployed to it, it's a fully standalone independent unit. So it is a provisioning node independent of any other kind of connectivity. So even if it loses connection to Lighthouse for whatever reason, you can still rebuild your network. You can still do all those provisioning operations because those resources are all stored on site securely in the encrypted storage in the node. So in terms of how secure provisioning is activated, as I said, it's kind of like these modules. So it's a modular system. So they're deployed as Docker containers. So we actually ship our code to Docker Hub, and then Lighthouse is able to sync with Docker Hub and be able to pull that code in. Then Lighthouse actually runs a little mirror of the registry, and it can push out the remote container that does the DHCP and the file serving and things like that out to the Opengear node. Then your operator uses Git or the GUI basically to check in all the config files, and also a manifest that says which config files are kind of bundled together with which firmware image files and how they should be distributed around the system, which nodes these bundles should be pushed to.
How do you determine a node?
A node is basically it's just our terminology for one of our physical.
So you mean node for your appliance? What I'm wondering is how do you determine which endpoint device is supposed to get which config and software
yeah, sure.
image?
Yeah, so there's a few ways to do that. So one is you can match up. So basically, when you're defining these resource bundles, you can set MAC addresses, ranges of MAC addresses. You can have reverse matches as well if you've got like one special kind of device. And you can, some of the ZTP processes, because the thing is, I guess, every vendor's implementation of ZTP is subtly different. Mm-hmm. Yeah, so some, like in particular iOS XR, broadcasts its serial number, so you can determine by serial number, so you can have a range of serial numbers and things like that.
So you are doing the work of figuring out what the ZTP process is for different types of standard devices,
yep.
and then providing that to the practitioner to kind of pull in and say, it's going to be this iOS device, and when I say it's going to be this iOS device, I need the MAC address.
Yep.
So you tell me which MAC address it's going to be.
That's right.
If it's iOS XR, you say, okay, well, I'll get the serial. We can do it that way too.
Yeah.
So that just gets presented in your interface.
That's right.
For matching those things up.
Yeah. So that can either be configured via the GUI, and you kind of got a list where I can show you it in a sec, or you've actually got a YAML file where you can just basically import a whole bunch.
Right. If you have the whole list and you can,
from your inventory system or whatever.
Drop it in.
Yeah.
Awesome.
So I mean, I guess the idea behind it is you don't really need to know all the intricacies of the ZTP per vendor ZTP process, because we support Huawei, Arista, Juniper. I'll show you the list soon. But basically, all the major vendors, you basically just have to say, I want to get this config to this device. That's all you need to know, kind of thing. So.
And is that list of supported vendors just always being? You guys are working on that in the back end. If a customer had something specific, they could come to you and say, hey, can you build out this process because vendor Y isn't supported yet, or?
Yeah, so they can absolutely come to us, or they can implement it themselves, because they're just like little ISC, DHCP.
Even better answer.
Yeah, snippets, and they just basically can create the templates themselves. It's pretty straightforward and documented on our knowledge base. So.
Okay.
So basically once the node is kind of orchestrated by Lighthouse and turned into a provisioning node, and that's where the kind of the ZTP process kicks in, and those managed devices, those switches and routers and things will boot up, and they'll start fetching their configs. And the WAN comes up. Everyone's happy, still happy.